Okay, so today we're going to be writing the names of compounds again, like we did the other day, but we're going to use a different section of our flow chart. Oh, I need to probably post this flow chart up. Oh. Okay, so I'll be posting a flow chart in the Google Classroom as well, and like I said, I will clean up the PowerPoint version so you can use it as well. All right, so just like the other day, we have to have examples to use. So we're going to start with CCl4. Okay, we're going to start with CCl4. All right, so even though we're just learning one section of it, I want you guys in the habit of always starting at the start. So does this one begin with hydrogen?
No.
No. Very good. Is the first part a positive ion / a metal? So the first part is C, or carbon. We look over here. Carbon on the one I colored in is yellow, and for yellow, it is a non-metal. All right, if you didn't know that. And again, the other way to know is it is above the staircase. So it is not positive, it is not a metal, so we go down here. Two non-metals have two names. All right, technically the second one is going to be optional, but for today we're going to learn them both. All right, the first method is the traditional method and the one that they went back to. The second method they started going to for a while. They've kind of gone back and said, you know what, that was a stupid method, which I agree, it was kind of stupid. However, you will still run into it, so I want you to be familiar with it. On the test, which method do you need to do? Probably the first method. What I think I'm going to do, I'm kind of rewriting my test right now. I think I'm going to do is the ones that are like this. If you write it with both methods, I will give you a bonus point for writing it with both methods. However, if it's one like we did the last time, the ionic ones, and you write it with both methods, I'll probably take off a half point because I don't want you getting in a bad habit of just thinking you used all of them in both methods. So I haven't quite worked out the details in my head. There's going to be a debate in there this weekend, and I'll let you know who wins. So it's kind of a joke because it's in my head. All right, so the first method is going to be to find or identify. Identify is probably the more appropriate term, but then I would make the box bigger. So find the prefixes indicating the number of atoms for each element, and then there's a lot in this box. We're going to write the names of each element with its prefix, change the suffix of the second element to IDE, and if there's only one of the first element, you do not have to put a prefix on it. All right? So what is the prefix for one? Mono, okay? There is only one of the carbon, but you never start a compound out with the term mono. All right? I don't know why, they just don't. So if there's only one of the first element, we're just going to write it as carbon. Okay? And then what's the prefix for 4? Do you guys remember? Tetra, very good. So we write the second one, we're going to say tetra. Oop. And then chlorine will become chloride. So tetrachloride. All right? That's not too bad, is it? I like this method. If they went to one method, this would have been the method I think they should have adopted for everything. Because it's simple. Because it tells us exactly how many's there. Carbon, 1 of them. Tetrachloride, 4 of them. Right? Simple. But the second method, so silly. All right? The second method, what we're going to do is basically adopt the Roman numeral method from our ionic compounds. But if it's two nonmetals, they're covalent. They're not even ionic. So I don't like that they came up with this method, but they did. All right? So, oops, I went too far. What we do is we pretend or assume the second element is negative and calculate a pretend or apparent positive charge for the first element. They are not positive, but we're going to pretend they are. That's why I don't like this method. it was kind of a short-lived thing, but I still run into stuff. So why should you know it? Let's say you're in college and they send you in the storeroom. They rarely do this, but they say, hey, we need you to get the carbon tetrachloride, but they've got an older bottle, so it's not labeled as carbon tetrachloride. You need to be able to identify, oh, it's also this compound. So, and it's really sad. It's like any, like car guys, if you don't understand the terminology they're using, they think you're dumb, even though it's just you don't know about cars or whatever. Every industry's kind of like that, you know. It's kind of like when I use, you know, young people terms wrong. I do that on purpose. I'm actually pretty hip, but you run into that, and so it's just good to know it. All right. So we go with the CCl4. We do it just like we did for the ionic ones. So how many carbons are here? 1. So we do the 1x plus how many chlorines? 4. What's the charge of chlorine? -1. And the whole thing is equal to 0. So we go x minus 4 equals 0. Add 4 to both sides. X equals 4. So we would write it then using the Roman numeral method like we did with the ionics. And so we're going to say carbon, Roman numeral 4. And then the second element we're going to do just the same way. We're going to say chloride. Okay? And last hour, a couple people, when they were doing their practice ones, they were still putting the prefix on the second one. You don't put the prefix in this one if you use this when you use the second method. All right? On today's assignment, I'm going to have you do the first half with both methods, and the second half you can just do with the prefixes. I think you'll get plenty of practice with it, and we do the Roman numeral system with the ionic, so I don't think you need to do all of them that way. I'm not just about torturing you most of the time. All right, let's do another one, shall we? All right, let's look at N2O5. N2O5, are you with me? All right, so in this one, let's go through our steps. Does it start with hydrogen? No. It's the first part a positive ion. Nope, it's yellow on my periodic table, so it is not. All right, so 2 nonmetals have 2 names. All right, find the prefixes. So what's the prefix for 2? Di. What's the prefix for 5? Penta. All right, so since it's not 1, we do use the prefix for this one. You do not change the ending on the first element. So it will be dinitrogen. And then, now, it gets a little weird because oxygen starts with a vowel. So we don't say pentaoxide, we just say pentoxide. All right? Again, I'm lenient on this area of spelling on the test. So if you did say, oh, you don't have enough experience and you put pentaoxide, I don't take off for it. But if you look at it and go, oh, I don't think that sounds right, yeah, it's pentoxide. All right? Does that make sense? Prefix method is by far my favorite. All right? And then we do the second method, which is the Roman numeral method. So it would be 2x plus 5 times -2 equals 0. All right? And then 2x minus 10 equals 0. Add 10 to both sides. 2x equals 10. So x would equal 5. All right? Everybody with me? Just some basic algebra. So we would write it as nitrogen, Roman numeral 5, oxide. Okay? And somebody asked me last hour, they said, well, like this one, it was 4, and the prefix was tetra, which is 4, and this one's 5, and the prefix was 5. Could you just do that? It works on those two. It does not work all the time. And I'll just show you. We'll just do one more real fast. Yes, whenever you use Roman numeral, whether it's this style or with the ionic ones, Roman numerals should always be in parentheses. Yep. And it's just the standard. I don't know why. But when you say it, you would just say nitrogen 5 oxide. All right, let me show you one where it doesn't equal the prefix. So if we have NO2, okay, and NO2 would be, how many N's is just one, how many O's is two, so one is mono, but we don't have to put it on there. Two is di, so nitrogen dioxide. Okay, when we do the math, it would just be X plus 2 times negative 2 equals 0. So X minus 4 equals 0. So X equals 4. All right, so what this would be nitrogen Roman numeral 4 oxide. Okay, so what I wanted to point out, like I said, somebody last hour, and it was a good observation, noticed on both these that the charge was the same as the prefix of the second one, but in this case, it would not be. Does that make sense? Are you with me? Okay, so on today's assignment that I'm about to pass out, there's 20 problems, but it's going to be 30 points. On the first 10, do both methods. Second 10, do just one method. Or just do the first method, the prefix method. And you should be able to finish before the end of the hour.